All right, let's roll. So thank you everybody for joining. Thanks for coming. I really do appreciate it. So this is Data Replicas, Digital Twins, and AI, oh my. Why software decisions will make or break your automation ones. And we're going to talk primarily, as you could gather, about software. We're not going to talk too much about robotic systems. There's definitely a lot of that on the floor. My name is Keith Moore. I'm the Chief Product Officer for a company called AutoScheduler AI. We're focused on distribution center orchestration, optimization, a lot of integration with warehouse management system. We'll kind of talk about adjacently some of what we do, but mostly this is to talk about like what is a digital twin? Why would you use it? What is artificial intelligence? Does it mean anything? So let's go ahead and get started. 3 key things we're going to go through today, right? There's a lot of technology buzzwords you guys are hearing. Unfortunately, there's only becoming more and more introduced to the industry as somebody has a new marketing catchphrase. And so we're going to talk about how do you actually frame these on a value complexity scale as it pertains to warehousing and distribution. We'll talk about the value of each technology, what it's actually designed to do, where it helps your operation, and then a roadmap to how you can use software to enable your system and enable your distribution center to better leverage robotic capabilities or automation capabilities that you are introducing. So with that, let's get rolling. I like to open with this. I stole it actually from the utilities industry. But the warehouse of the future is a man and a dog, right? You hear, I don't know if anybody's heard it before, but you ask, like, what? That doesn't make any sense. What is the dog there for? Or sorry, what's the man there for? Well, the man's there to feed the dog. What's the dog there for? The dog's there to make sure that the man doesn't touch anything. And so we always talk about dark warehousing, and dark warehousing, we're actually introducing more and more automation to different sites, and we're going to let all the planning, all the distribution, all the logistics kind of handle itself. The reality is nobody's there. Very few sites in the world are there today. And so, I'll talk to a lot of our customers. Most of our customers are big consumer goods companies. And we'll say, hey, we want to automate the process of allocation in the WMS so that way you guys don't have to do it. And a lot of sites are like, oh shit, sorry, language. Don't do that. Like, we have a person that does that. You don't want to touch that button. And I'm like, okay, well, how in the heck are you ever going to get here if you're not even willing to let one decision be made by a robotic or an automated system? And so the reality is the adoption is not as fast as we want, even though I think everybody's aligned on where the goal is going to be. And so let's talk about some of the technologies that help us get there. I have a smorgasbord of technologies that I like to talk about, and so you've probably heard of a lot of these that can help you drive efficiency from where you are today. You have things like warehouse management systems, data replicas, yard management systems, artificial intelligence. I want a digital twin and blockchain augmented reality, right? All these different things that you hear about and you talk about. Unfortunately, I only have about 30 minutes to talk about these, so I'm going to go ahead and cut a few out. We are not going to talk about blockchain today. I understand smart contracts are a thing. It is not super relevant to most warehousing software. I will fight somebody on that later. Augmented reality, I also recommend that this is a new technology that is starting to drive change and has a lot of potential. But we're not going to cover augmented reality today around pick path optimization, things like that. We're going to talk about the rest of these. So to do that, let's talk about where we want to go, right? We want to drive the highest value for our distribution centers while spending the lowest amount of money. And so I actually have a way to score them, which is, what is the implementation complexity, often associated with money, and what is the value that you're actually getting out of them? With all the automation vendors, and I know everybody's walked the floor, and it is mesmerizing and very difficult to take in everything that you see on this floor because there's just so many different things. The future of our industry is in implementing robotic systems in distribution centers. So let's talk the softwares that will actually help us get there to a more optimized distribution center warehouse that is running robotic systems. And so if we build out this value curve, kind of built it out as such, there are certain technologies like a YMS that are really easy to implement, low complexity, really valuable to sites still, but kind of on the base level. What is the complexity? What is the value? And you really see there's a fairly linear relationship between introducing some of these softwares and the value that you derive from them. And so we'll walk through each of these in scope, and there's actually one quick thing I want to address before we go too much further. So I guess I didn't go too much into my history, but my history is control systems, test and measurement, mechanical engineer by training. I spent 5 or 6 years taking a really small company in Austin, Texas to a unicorn focused on pure play artificial intelligence. So I have a bit of a background in AI. And the term AI really bothers me. So you guys are all here to hear about digital twins, data replicas, and AI, oh my. Well, what the hell is AI? Because it's pretty much ubiquitous for anything that's going to learn and make your system smarter, right? Well, it turns out there's a whole subgrouping and ontology of how you can actually think about AI. Is it machine learning? Is it natural language processing? Is it convex constrained optimization approaches? There's all these different things that you can use to be AI in a system to make distribution centers more intelligent. So instead of saying AI, I like to use the term advanced mathematics because it's a much more broad topic, considers fields of study like operations research that are immensely valuable, but often not bucketed under AI by whoever's creating the labels. So advanced mathematics, and a rule for people to understand if AI is relevant to pretty much any project, any way, shape, or form. This is something I formed a while ago, and it seems to actually hold true in most cases, is if you ever replace the term AI with math, and it sounds stupid, it is. And so when somebody says, we want to use AI to do blank, and if math doesn't make sense, it doesn't make sense. So let's talk advanced mathematics instead of artificial intelligence for the rest of today. But what I want to kind of talk about is how do these technologies chain together to actually drive further and further value for your site as you start to introduce robotics, right? This is not a one-stop shop. You generally don't pick and choose. There's actually a roadmap for implementing these things so that you can drive more and more value because something can build on top of the last software solution that you put into place. So let's go through what each of these are. So driving value. In order to drive value, I need data, right? Data is the new oil. You hear that so many times, it hurts, right? But it is important to have good data about your distribution center and your warehousing operations. Generally, if you have a warehouse management and a yard management system, that is a good way to understand if you have ground truth data that your site can even operate off of. So I understand WMSs do a lot more than this, but when we're talking about what is ontologically required to support advanced robotics in the future, we should view warehouse management systems and YMS providers as the most valuable data providers that exist, because they're going to be telling us things like, what inventory do I have? In what locations? What do I have on the yard? How long have trailers been on the yard? What does my work queue look like? Meaning, what tasks are people going to be performing on the floor? How many shipments are going out? What shipments are coming in? What appointment times do I have? This is where all of that data is kept, most of it in warehouse management systems, but some of it in yard management systems. And generally, most of those integrations are put together. And so on the right-hand side, I've actually added a few key vendors. I understand, as big as this show is, I'm not trying to offend anybody. I just added a few vendors that our customers are working with. On the right-hand side, if you're trying to understand who are the providers in this space, and who are some folks I could talk to if I'm trying to understand a little bit more about what a WMS or a YMS actually does. But from a value perspective, like, we care about them as software developers or as companies that are trying to build more intelligent distribution centers because they give us data. So we have data. We have a method for collecting data because they're integrated with scanners and everything else that you have. What comes next? Making that data visible. So you guys have always heard what is the roadmap to being a really intelligent system look like? It's, well, first you need visibility, and then you need predictivity, and then you get to be prescriptive about your operations. So the next thing is, if we have the data, you need to actually be able to use it. Depending on what your warehouse management system was implemented, it might actually be hard. Or if it's a home-rolled system that doesn't have really good integration points, there's a whole industry that has kind of started to evolve over the past 3 or 4 years around data replicas, and that is what they are for, is how can we get all of this data that exists, potentially in different systems, bring it into one place so that I can understand what's happening. Things like dashboarding. How can I query everything that's happening in real time? How can I get alerts on when a shipment is short or something's on the yard and it's in detention, but I don't want to go over to a pink, or I don't necessarily know which screen to look at. These types of data replica technologies pull all this data into one place, make it really easy to analyze, and really easy to use for future applications. Some big providers in the space, so Longbow Advantage, Rebus, they have a booth. I actually don't remember their exact booth number, but it's that direction in building C. I'm sure you guys can find it in the app. Get Us ROI, there's kind of a limited number of people that are playing in this space. So what I find with a lot of our customers is, and I bet a lot of folks have heard this, is we say, hey, well, how can I access your data? It's like, oh, you can use our data lake. And it's like, oh, okay, well, how easy is that data lake to interface with? What is how real time is that data? If we're making execution decisions in a warehouse, I don't want data that's a day old. I want data that's 2 minutes old, at worst, right? And so that's where these technologies are really valuable. They've built out capabilities to pull that data out of warehouse management systems and in real time sync that so it's all accessible for other applications to kind of build on top of as a backbone. So data replicas. The next thing is digital twins. What is a digital twin? As an engineer with an engineering background, not necessarily in supply chain my whole career, when I think digital twin, I think of like ANSYS type technologies. I'm building these massive mechanical models, dropping them in open worlds, and simulating a bunch of things to see what shit breaks. I don't know the swearing rules on this, and I apologize. That is kind of what I think of when I think of digital twin. It's the tool engineers are using to figure out when there are going to be problems. Well, are there digital twins for distribution centers and warehouses? Yeah, absolutely there are. And again, the list is limiting, and I'm a little bit self-serving here on what this does. But the goal of a digital twin is to model the future of a warehouse in different situations over time. What is going to happen in your distribution center? And most importantly, what are the problems going to be? So this is when we start to get into the predictive nature of warehouse operations. At which point, is there anybody here who considers themselves pretty good at machine learning? Okay, no volunteers. I get a lot of questions on, can I use machine learning to forecast what's going to happen in my warehouse? The answer is maybe. But when you talk about technologies like machine learning, and we'll talk more about artificial intelligence and advanced mathematics in a second, machine learning builds approximations and forecasting builds approximations for the future, but they're not necessarily going to be right. If you were making execution decisions in real time to deliver on that future and you end up being wrong, you're in a really bad state. So for everybody here in supply chain, how many of you guys have seen a forecast that was wrong before? Yeah, you don't want to run your warehouses off of forecasts, right? So why digital twins and operational twins are valuable is they give you a full simulation environment to understand what is more realistically going to happen in this particular setting, however your distribution center is laid out. And so as an example, this is a really simple example. Let's say I'm looking at inventory, again, consumer goods problem, and it's 12 o'clock and I have 300 cases of this product. I might get a notice that says, hey, you're going to be short tomorrow at 7 o'clock in the morning. And you're like, well, how do you know that, digital twin? And you can say, well, it turns out if I play forward what's going to happen in the future, I have a truck coming and it's pulling 50 cases at 12:15. I have a truck coming at 4 o'clock that's going to leave me with 125 cases. I have a receipt that's supposed to show up at 8 o'clock. We all know how timely receipts are, and any trucks coming to the yard. And it's actually going to bring me another 25 cases of that product. I have 2 more going out, leaving me with 25 cases at 10 p.m. And at 7 o'clock, I have a truck coming in to take 50 cases, and too bad, Walmart, you're going to be short. We're going to pay fines on that, right? That is the type of thing a digital twin is doing. But depending on who you're working with and what they're doing, you can get much more granular approximations of where you're going to have issues well in advance. What are your labor issues? What are your capacity issues? What are your space issues? What are your inventory issues? What are all these things that I just don't have the time as a person to consider that I can get ahead of so that I can just completely resolve them in the future? That is what digital twins and operational twins are designed to do. But there's one thing they don't necessarily do. So they'll call out problems. They'll identify where they're going to be, when things are going to break. But you basically want to operate in such a way that you don't run into the scenario where it breaks at all. Is there anything I can do to modify my behavior now so that that failure doesn't occur in the future and maximizes my objective, which at most, customer-facing distribution centers that are consumer goods companies, that's, let's maximize fill rate, let's maximize on time in full, and minimize distance traveled, money we spend, capacity, or maximize capacity, the whole 9 yards. This is where the prescriptive piece comes in. So we've talked about technologies. Let's get the data. Let's go ahead and build on top of that data so that we have something that we can access the data. So use a data replica to actually access our data and use it for better purposes. We can use that data, plug it into a digital twin, understand what's going to happen, and then we want to prescribe what should we be doing about it. So how can we actually leverage that digital twin to understand what work could I be doing now to make sure I don't run into problems in the future? And there's a few other key vendors that play in this space. Once again, this is something we do at AutoScheduler. And the term, this is where advanced mathematics can come to really help you. The first thing you need to be able to do, though, anytime you have a problem, is say, what is my objective? What do I want to accomplish, given I have all this software that is helping me understand the current state of where I am and where I'm going to be? In order to prescribe the optimal workflow, you need to have a goal. You need an objective. And so the term prescriptive actually really fits, because you say, well, I'm sick, I'm going to prescribe medicine, or I'm going to get prescribed medicine so that I can actually get healthy again, right? Well, same thing for a distribution center. But in this case, we needed the objective that tells us how do we maximize throughput at our site and really get every little bit of work done that we possibly can. And so an example of where a prescriptive solution would come into play is you could look at a digital twin. The digital twin could tell you, hey, you're going to have an issue on this shipment because it's 9 o'clock in the morning, or maybe you're potentially up to an issue. It's 7 o'clock in the morning, and you have a trailer going at 12:30, and it's risk of being late. Well, why is it a risk of being late? A prescriptive solution could go in and say, well, no, turns out we're not going to cut inventory, and that trailer's not going to be late, because what we're going to do is we're going to say, okay, if I need to get that trailer out the door at 12:30, I need to start loading that trailer at 12. It's going to take me 30 minutes to load. So in order to get that trailer loaded for 12, I need to have everything staged by then, which means I need to start picking at 9 o'clock. It's a really heavy case pick order. So I'm going to do all my case picking, have it on the staging bay by 11:30, 11:45, load for 12, I'm all good. But turns out, I don't have all the inventory in the right place. So I have pick slots that aren't filled with the right inventory. So it turns out I actually need to replenish some of that inventory for 9 o'clock so that I can pick for 11:30 so that I can stage, so that I can load. And the inventory I need to replenish isn't even in the building, but it's on a receipt in the yard. So what a prescriptive solution would tell you is you need to bring in this trailer to this door at 7 o'clock. It needs to be unloaded for 8. It's going to be replenished for 9, picked for 11:30, staged for 12, loaded for 12:30. Ta-da, you don't have a problem anymore. We have just optimized that output. That is what a prescriptive solution does in a simpler sense, but in real world, you can get all the way into we are dynamically creating mission-based tasks that are like, think of interleaving on steroids, so that you are actually minimizing travel distance, maximizing output, and making sure you're doing all the work in a building as well as you possibly can. So that's what advanced mathematics can do, given you've built that software framework for success. So how do we actually get there, and why is this needed? I'm gonna change gears a little bit, because we've talked about advancing technologies and how they kind of build on top of each other, but why do we need this? So let's think about what actually happens in distribution centers, where the problems are, and how you can use these to really drive value and address gaps. So inventory comes in a gate. That inventory, as it comes in the gate, generally gets dropped in a yard. You're going to move from the yard to a door. That trailer gets assigned a door. You're then going to unload it to a staging area. That staging area, somebody's going to pick up and take and put in a rack. Right? There's your optimal inbound process for a consumer goods distribution center. And then for outbounds, another order comes up. You're going to say, okay, well, let's go get that stuff from the rack. Let's bring it to another staging area. And I need to assign the door and the staging area and everything. And I'm going to take that and move it to a trailer. So I'm going to load that to the trailer. I'm going to pull that trailer into the yard, and goodbye it goes, right? Out the gate it goes whenever it gets come to pick up. That was not appropriate English. Whenever somebody comes to pick it up. And so that's your ideal consumer goods distribution center. Unfortunately, none of them actually work like that, because that is a really cool, easy, linear process. But most sites are not like pallet in, pallet out. There's a lot of complexity, particularly when you get all the way down to non-consumer goods DCs and you're running full truckload, LTL, parcel operations. How do you balance all these different workers that you have? But even at like a slightly more complex consumer goods DC, you generally have processes like case pick and layer pick. So how do I figure out when inventory is going to case pick, when it's going to layer pick, when do I replenish that inventory, when am I actually tasking people to go case pick things, bring them to the staging area versus layer pick, and when can I use full unit loads, and how do I cost optimize for all these different decisions? But I might try to get a little bit smarter and say, well, let's just cut out the middleman. I want to do things like cross-docking. I was told the less you touch inventory in a distribution center, the better you are. This is generally true, by the way. And so I want to take inbounds, bring them into staging, cross-dock them to outbounds, and ta-da, I don't even have to worry about putaways and retrievals per pallet. It's going to save me $1.47 according to my labor guidance. And so it starts to get more complex the more processes you add. And most sites don't run this way, right? They might have a packaging station or a flow zone where they're trying to optimize inventory utilization, a near-door staging so I can pre-stage so that I can stage so that I can load. And once again, every time you introduce a new flow to a site, you add more arcs and nodes, right? This is a combinatorial optimization problem. The more you introduce, the harder it gets because the more decisions that have to be made. Some of you guys may be familiar with problems like this, like the traveling salesman problem. But distribution centers can basically be baked down into a series of flows for optimization. But it gets harder because not everybody can do everything. And so when you actually look at the flow, there are certain things that have to happen in the yard and certain things you might have reach trucks or clamp trucks or forklifts doing. You need people in a case pick zone and people on a layer picker, and they all have different capacities and they all move at different rates. And you need to balance all of those things as a planner when you're trying to make decisions, when you're using all these different softwares that you're given. And so basically, when we think about how these softwares play in, your WMS is saying, well, I know what's where when. My visibility tool, when I look at this process, is telling me, okay, I'm going to get this data to the cloud. My digital twin may actually be able to map through this process for me and tell me where am I going to run into issues. And then what the advanced mathematics is doing is telling me, given all of these flows, I can give you an optimal plan so that you maximize output, minimize cost, and the considerations around inventory, labor, et cetera. And then you introduce automation. And you're like, oh, shit. This got harder. Because nobody, we talked about dark warehousing, that's where we're going. But it's very rare. I won't say it's never happened, but I would say it's very rare for an organization to say, I think we're going to introduce automation at one of our distribution centers. How about we just get rid of all the people and just have it completely automated? Let's just go dark in one go. Nobody does that. They say, well, I'm going to introduce an ASRS, so automated storage and retrieval system. I'm going to introduce AGVs, maybe a layer pick operation, case pick, something else. And so you start to add these systems that, once again, use different actors. So an actor being somebody on a forklift, an actor being an AGV. They can kind of be treated interchangeably by mathematics with just different capability sets. And you're introducing all these different actors and all these flows, and you're creating this friction of human-robotic process handoff that is really hard to handle at a lot of these sites. So we all agree, I hope, that the future of the industry is robotic systems and automation. But unless it's introduced intelligently, the capacity it brings might be minimized. Because you might have an ASRS bring something to a spur, but then something's going to sit on that spur for 4 hours until a guy on a forklift is able to come pick it up and actually put it where it needs to go, right? The ideal is it gets dropped off, you get picked up by a person, and everything is completely orchestrated. And so being able to actually maximize the capacity of these systems that never tire and very rarely need to be repaired requires a little bit of forethought. And for people today, that forethought's really challenging because not only are people actually looking at all these flows and all these processes, they're also doing things like allocation. So in the building, people making decisions on who's doing what when have to figure out when am I releasing inventory to the floor? Who is getting what inventory? When does it actually go into the work queue? So how are we basically, when do I actually take that work, make it available for somebody to pick up and use? And then how do we prioritize it? Who should be doing what? Is there a different way that we want to increase priority of tasks, decrease priority of tasks? What do we send to layer pick? What do we send to case pick? What do we retrieve from the ASRS? And what do we pull from the rack that's down on aisle AA, aisle A? We'll call it that. And so the people that are actually making these decisions are the most constrained. And that's kind of why we're doing this. That's why we're talking about all of these softwares that can help make their life easier. So what does that look like in the end, right? We've talked about the blanket vertical of having a warehouse management system and a yard management system to get the data. We've talked about a data replica to make that data available for us so that we can bring it all into one place. We've talked about digital twins to tell us we're going to fail in advanced mathematics for telling us how not to do so. But what this means, and really the type of software that helps bridge all of these things together, are decision support systems. According to Gartner research, it was the second most funded initiative in supply chains last year. Behind, oh God, what was it? I want to say, what is it? Just introducing technology, digitization, that's it. Behind digitization, implementing some form of decision support software was the second most funded initiative. So kind of everybody recognizes that's where we need to go. But really what we're talking about when we're talking about having a WMS and layering on top of that WMS and YMS and all this data that you're getting for your distribution centers and bringing it into one place, figuring out what your problems are going to be with your digital twin and then actually optimizing around it, is you are building a big decision support system that's able to tell you at any point in time, what should I be doing when should I be tasking things, how can I maximize output, and how can I minimize all the things that I want to minimize. It's completely different for a fulfillment center versus what you're going to see in consumer goods. So I think that is it for me. I wanted to go fairly quickly because I thought there might be questions or people that are angry at me for my stance on technology. So if you are really angry, come visit me in my booth, C5471. If not, I'm more than happy to take questions. Going once, going twice. Thanks everybody for coming out. I really appreciate it.